Welcome back. This week we're reading this paper by Dennett titled Cognitive Wheels, the Frame Problem of AI. And note here that this is a relatively old paper from the 80s, way before the current deep learning paradigm and large language models. So first, why are we reading this paper? This week is focused on understanding some key questions about intelligent behavior. And so you'll see how this paper predicts and helps us frame a problem about intelligence and artificial intelligence more broadly. And as we go further into the current deep learning paradigm, we will notice that this problem has not been overcome. This is a problem that applied to those systems that Dennett is arguing about from the armchair. As you'll see, his presenting us a thought experiment, which is very helpful for philosophy, for cognitive science, and for thinking about AI systems, as in many cases, we may not have the systems we care about available. You'll realize that that is the case with artificial general intelligence and superintelligence. We do not have these systems, and yet we're interested in speculating about how they would behave, what properties they're going to exhibit, and how we could make these systems understandable, explainable, and controllable, which is the AI alignment problem. And in this paper, Dennett begins with this thought experiment. And he says, imagine that there is a robot, R1, and its goal is to go retrieve its battery from a room with a time bomb. So because of this bomb, the robot would be understanding that its survival relies on finding the battery. And it executes the plan pullout, but he fails to notice that he pulls the bomb out as well. So what does this mean? It means that while the robot understood one chain of causal direction, of cause and effect, it was not able to notice the possible side effects of his action. And you see this better in this illustration here, which is something fairly simple. And you can understand that for all sorts of cause and effect relationships, that there is a cause and it may have many different possible effects. And unless we are able as intelligent agents to distinguish between those effects that are desirable and those that are not, we will not be able to achieve our goals. So this is the problem Dennett diagnoses in this paper. In other words, how can we specify what remains unchanged after an action? The cause, the different effects, what is it that does not change through this causal interaction? And even more, then it points to this problem of how can we discern between consequences of an action or a cause that are relevant versus those that are irrelevant to the desired outcome. And this is a big challenge in the study of artificial intelligence and cognitive science more broadly. Now, why is this such an important problem? It's not just something that we could easily fix by doing something different in our programming and engineering. It's a deeper problem that intelligent agents encounter. And it's an epistemic limitation, in a sense, that under different circumstances, it might be difficult, it might be challenging to tell between what's relevant and what's not in this kind of cause and effect connection. In many cases, however, humans seem to be able to filter between relevant and irrelevant effects pretty easily, which poses a sort of puzzle about how would an artificially intelligent system imitate, perform similar functions as human brains. And it points out that intelligence and intelligent behavior is this selective, context-sensitive reasoning, and it heavily depends on the parameters of the specific situation. And this creates a series of philosophical puzzles and reminds us that there's no simple fix here, which is why we will see further on we encounter issues such as the control problem that you saw in Stuart Russell, or the alignment problem, which is the same thing. And intelligence, in many cases, is not just following rules correctly. It might include something more than that. And we're a bit uncertain about what that would look like. So what you can do, and what you should do, is go and read the paper by Dennett carefully and try to understand the thought experiment. We covered the core of the problem here, of the frame problem. And let's go back to the idea that this is a deep epistemological problem, as Dennett says. I'll go through the paper very quickly, just to give you a sense of what reading a philosophy paper looks like and trying to highlight some relevant bits of the paper. So AI makes it more evident that this is an epistemological problem, and we really don't know why and how, under what conditions, an intelligent system would be able to choose between relevant and irrelevant consequences. And you might be putting the pieces together here and already getting this idea of this could eventually lead to misalignment, because a model, an intelligent system, could be arbitrarily choosing between different effects. And it might be unclear or very difficult to ensure that it chooses the correct effect, therefore the desirable causal path. And here you see how Dennett traces it back. He says, why hasn't anyone else articulated the frame problem clearly? Why is it so difficult to even specify what this problem is about? And he mentions different philosophers. McCarthy is a philosopher of AI and computer scientist from Stanford. Dreyfus and John Searle, also philosophers that were interested in AI and how intelligent behavior would behave in different ways. And he's not really trying to give a solution here. Like I said, he mentions several times that it's very hard to even articulate what the problem looks like. So if that's clear to you, that choosing between what the relevant and the irrelevant consequences are from a given cause, and this is problematic and this is difficult, this is pretty clear. But further, he goes back to Humean accounts of learning. Humean, from the empiricist philosopher David Hume of the Scottish Enlightenment, who you may know if you're familiar with Introduction to Philosophy material from the problem of induction. So he connects this problem of cause and effect to the problem of induction and how learning takes place. And here you'll see different terms such as phenomenology, which is the introspective method, being able to understand one's own experience via introspection. But like I said, he's not giving us a solution. He is pointing to different directions and different parts of the literature. So it's worth reading a bit more closely and try to make sense of how is Dennett trying to make progress here. And as you'll realize, in many cases in philosophy and cognitive science and now AI safety, we might not be able to give one single solution or a satisfactory answer, but rather we might just have to clarify the problem and put it in terms that make it easier to break it down into smaller problems and try to understand. So for example, here, trying to take this bigger problem of discerning between what remains unchanged and different kinds of outcomes and consequences into smaller problems about learning and causation and the connection between cause and effect, and how do brains and minds establish questions like that. So this paper is a great opportunity to start thinking through the problems of intelligent behavior. And again, keep in mind that this applies to all sorts of intelligent systems, and it precedes the current deep learning paradigm and large language models. So it's even more interesting to know that there is philosophy out there that has predicted problems that technical work is trying to make progress on right now.